So here we have a drawing where we have a weight hanging down. And we have two angles. Now if this is in a nice static situation, then we know that the force pulling this way, and the force pulling this way, and the force pulling this way, all add up to? Zero. Now, whenever we have three forces that are adding up to zero, then we can turn them into a triangle. Yeah. So, how would we line these up to make a triangle? Right now, they're all tail to tail to tail. That's not good. We want to head to tail them. So, yeah. So how do we head to tail this and make it look like a normal triangle?
Get down here.
Anybody?
I see it.
The one that's at the 38. Put it at the end of the 60. Like where the arrow of the 61 is, you can put it at the tail.
Where the arrow of the 60 is. Yeah. We can put this one?
No, like. Okay. Put that 60 one at the base of itself.
Move that one down.
Put the 60 at the base of itself.
Yeah.
So you want to put it there?
Yes.
Yeah, and then move the other arrow down.
And then you want to move this one to there?
Yeah.
Woo! So you want to put the 146 here. And if we'll call this side A, that'll still be A, and we'll call this one B. Okay, so if we do that, then what are our angles? Well, this one would clearly still be my 90. So that would make that the hypotenuse. And if this was 30, then this one's going to be, so this one's going to be, so you can get away with that. That will work. So then it's really simple because we just say, hey, the 60 goes with A, and which side is that? That is opposite, and this is, that is what? It's across from the 90, so that's going to be hypotenuse. So if we have opposite and hypotenuse, we want to use?
Sine.
Yeah, so sine 60 is going to equal A over 146. And the sine of 30 is going to equal B over 146. Is that right? Or if it's right.
Sure.
Algebraically, we do that. So you should have gotten that A is 126 and B is 73.
Yes. Sure.
Now, how come A is carrying more of the weight than B is? Yeah, if you think about the angle, if this is coming at a 30-degree angle, then more of it is going sideways and less of it is going down. The 60-degree angle, you have more of it going down and less of it going sideways. So if we're in equilibrium, then the total upward should equal the total downward. So these two components of that should equal 146, and the total to the side should equal the total to the side. Right? So if we're in equilibrium, then this side and this side have to cancel each other out, and the total down should equal the total up while these are pulling up. So these two are pulling up. So the 60 is pulling up and over, and the 30 is pulling up and over, and then we know the total of the up has to equal the total of the down. And the total right and the total left have to cancel each other out. So that's the idea behind it. Now, if it turns out real pretty like a 30, 60, 90, then it's a nice, easy thing. We can just do it easy like. But what if it's not a 30, 60, 90? What if we want to do hard stuff? Hard stuff. Okay, what if I say I have measured this one to be 196 newtons, and I know that this is a 41-degree angle, and this one turns out to be a 53-degree angle, and I want to know what is the tension in A, and I want to know what the weight of that is. How can we think that one through? What? I asked the impossible.
Well, you already have your B. You already have your B, so you could just.
Can we have the same format? Can we have the same triangle?
Okay, is this going to be a nice right triangle?
No.
Not even close, right?
Also not even no triangle.
But we can turn this into a right triangle
Is that right?
because this is going both up and to the right.
Also then we divided by 6.
So can we break that triangle up? Yes, over here we're going to use sine, and over here we're going to use cosine. So if we break that up using sine and cosine, we're going to have sine 41 times 196, and that gives me 128.5. And if we take cosine of 41 times 196, we get 147.9. Right? Okay, so that part's not hard. We know how to break up a triangle in this sine and cosine. That part should be easy for everybody. But now we say, hey, wait a minute. We know that if we're in equilibrium, then the total going to the right here has to be balanced by an equal amount going left. So if that was 147.9, then this needs to be 147.9. So then we say to ourselves, well, hey, compared to this angle, this side is adjacent, and I'm looking for the hypotenuse. So if I have adjacent and hypotenuse, then I'm looking for, yeah, I have cos. So the cosine of 53, because the angle is always stuck to cosine, is going to be the adjacent side, which we said was 147.9 over A. When my unknown is at the bottom, these two are going to trade places, so A is just going to equal 147.9 over cosine 53. And that's going to say that this is A is pulling with 246 newtons. So that part was easy. Now how do I figure out what the weight is? We weigh it. Yes, that would be exactly what we do. We know that the weight is pulling down, and we know if we're in equilibrium, of course, the total down has to equal the total up. Well, we already know that this up was 128.5. What is this up?
128. No.
Well, again, if I look at the one that I knew best, which was this one, this was the adjacent side, and now I'm looking for the opposite side. So I would use tangent, so I would say that tangent of 53 is the opposite, which I don't know yet, over the adjacent, which I did know. So then you get x by itself, that's going to come up here. And that came up to 196 newtons. So the total upward then is 196 newtons and 129 newtons. 196 plus 129. It's like a little puzzle. And it's totally easy to solve, right?
The one thing you got it from the other one, right? From the other, from the sign of,
Yeah.
41.
Yes, this is the one. So my total ups equal my total downs.
Yeah, right all
Now that worked out great if I give you one of the sides, but what if I would give you the weight
But no sides?
and just the angle?
You redo the triangle stuff that we did.
Now the algebra is going to get a little trickier.
You can reach out again. There's a physics down.
So let's say we say that's 212 newtons. What angle do we want on the left? 44. Okay, and on the right we're going to call that?
69.
It looks smaller to me, but okay. 33. 44 and 33, that totally adds up to 9. No, it doesn't. Okay, so clearly this can't be made into a nice little right triangle easily from those three. But 55. Shh. Okay, so how in the world can we figure out what? Again, we'll call this side A and we'll call this side B. What is the tension in A and what is the tension in B? 0? It's not going to be 0.
Is that 218 or 212?
It's floating.
212.
Oh.
It's
212 newtons.
It looked like an 8 up on a 0.
So, what's the difference?
Okay, we know a couple things.
You
It's
get
equilibrium.
the angle.
Yes, we know it's in equilibrium.
A triangle's 1/8.
So we know this will equal that. Correct?
yes.
So can we figure out a formula for that? Well, A is going to be the hypotenuse, and compared to this is the adjacent side, so we're going to use cosine. So we say the cosine of 44 is going to equal A over X. Right?
Yes.
Yes.
And we know over here we've got the same situation. The cosine of 33 is going to equal, whoops, sorry, X over A.
Come on, sir.
Adjacent over hypotenuse. And this is going to be adjacent over hypotenuse also. And we said that the x equals the x, right?
Yeah.
So if I want to get x by itself, then A comes up here,
Ooh, I see what you do.
and B comes up here. Now, if x equals x, then yes, A cosine 44 is going to equal B cosine 33. So I've got that going for me, which is nice. Do I know anything else?
The weight.
We know the weight. if we know the weight, what do we know?
You know the ways.
What are the acceleration?
Down.
We know the weight going down equals
The weight going up.
The weight going down.
the weight going up, right? So we know the weight going down equals the upward components of the other two, right? So in this time, we're not going to use cosine, we would use sine.
Sine of 44.
So we're basically going to say A times the sine of 44 plus B times the sine of 33 has to equal to 12. Now the problem is both of these equations have two unknowns. So what do we want to do to get them to equal one unknown?
You solve for one of them and then replace them.
Solve for one and shove it into the other one,
Okay.
right? So if we want to solve this, we're going to solve this bottom one for A. All I need to do is take this section and put it under here. Right?
Now you can replace A and
And now, since I know what A is equal to, this whole mess, I can shove it in up here. So I'm going to end up with B cosine 33 over cosine 44 times sine 44 plus B sine 33 equals 212. That make sense?
E.
Yes.
E.
So now we have a bunch of numbers. At this point, it's easier to just simplify. So if we simplify this, we calculate everything that's not B. So cosine 33 times sine 44
bless you.
divided by cosine 44 will give me the nice number 0.81. So B times 0.81 plus B times sine 33, which is 0.54, equals 212. This making sense?
No.
How is that no?
Because I put a cosine instead of a sine.
Okay. So if we have this, we have to add then the 0.81 plus the 0.54, which gives me 1.35b equals 212.
Okay.
So then to find b, I want to divide both sides by 1.35.
What is that?
And we find that b is equal to 157 Newton.
Wait. Just a step before that.
You divide
I added these two together to get 1.35, and then I moved 1.35 over here. And now that we know what b is, of course, we can shove b into either one of the earlier equations that we had and solve for
A.
a.
You showed us the first one.
So that would be the first one, would be the easiest one, the one that I erased. So the one that I erased, of course, we said
Oh, A equals B.
a cosine 44 plus B, which we now know is 157 times cosine. I'm sorry, it's not plus. Stop it.
It's equal, no?
Yeah,
Probably.
that's equal.
So,
Equals 157 times cosine 33. So then to find A, I'm just gonna bring
yes.
Sine 44 down.
cosine 44 over yonder.
Wait, cosine.
Yeah.
What the heck?
Stop. Get out of here.
Then why is mine sine? Yeah, probably.
So A should
Yes.
And that gives us A is equal to 183 newtons.
So you're not ready, Caesar?
That was fun, right?
Yes.
Yeah, that was.
We like that. It makes us think algebraically. Oh, this. Miss Lopez would be so proud of you. She wouldn't have chocolate.
She would expect this.
She would expect you to know how to do that. Yeah. Okay, moving on. What if we had
Oh, that looks funny.
a weird setup like this?
Funny? What kind of English is that?
This is way far more funner. Okay, let's say that M1 is 14.5 kilograms, and this makes a 139-degree angle, and this comes out perfectly horizontally. If this line comes out perfectly horizontally, how big is M2?
Wait, let me just process.
I will give you a moment so that you can draw the picture.
I want to wait. And now one last thing. I like Twix because it's my favorite. Snickers and
Yeah,
39.
What if we do this on the board?
that's 139 degrees.
What if we do this on the
I would agree.
Mario, your hair is weird. Mario, your hair is weird.
Okay.
Is that
Wow.
Okay.
Oh, my bad.
You should make one. Yes.
Yeah, you should come out in one of the
At least.
Just like that here.
Yeah.
Are you done drawing your drawing?
I like my Austin. Austin, your mask is coming out of the video. Austin. Okay.
Every test.
What the
It's
Air pressure.
Yeah,
It says
I think it's probably just like air pressure.
after this is 14.5.
Okay, again, this weight is going to pull this way, correct?
Yes.
And this weight is pulling that way,
We make a triangle.
and this weight is pulling this way. And we say again, those are in equilibrium, so we can make a
Triangle.
triangle. What's nice is that this one does in fact have a 90 in it. So we say, hey, that makes the math so much easier.
You guys say 14.5 kilograms?
Nice
Yes.
to me.
14.
So, to turn this into a force, of course, I have to multiply this times 9.81. So if we have 14.5 times 9.81.
That's a tension.
That gives us 142 newtons of force pulling downward. And again, we would like to head to tail these. So how can we head to tail these in a nice, meaningful way? Well, what I'd like to do is I would like to take this one
And shift
and move it over to here.
and then make the angle up.
And then I'm going to take the 142 and put it here. So I know the 142 is going to be right here. But what is this angle going to be?
It's the 139 minus 90.
No,
Minus
minus
180.
Thank you. If I move that over and keep the angle the
Sorry.
same, then that means this angle is still 139. And so this would be its supplement over there. So the supplement of 139 is not from 90, it's from 180.
Sorry.
21 degrees.
41. So that's going to be a 41 degree angle.
Aside.
And again, I know what this one is, so I'm just looking for the mass of this, which is what's pulling on this one, so that's
So
what's
it's that-
pulling on that one.
But friction on the wheel.
It's frictionless.
We're pretending that it's frictionless and massless and all the stuff that we assume so that keep the mass
Air
in the
pressure.
bulk.
Air pressure.
Yeah, but not the air pressure. So if this is 41 degrees, this side is
Opposite.
opposite, and X is the hypotenuse, so we want to use
You want to use
Sine.
And again, if my unknown is at the bottom, then these two are just going to trade places.
Sine of 41 is equal to 142 X is equal to 2.
Except I didn't ask what force is in this cable, which would equal the force in this cable, which would equal the weight. I asked for the mass, so that 216 I need to divide by 9.81. And we're going to end up with 22.1.
What were we looking for?
The mass.
The mass that we would have to put over here to get this to be a nice horizontal line.
Wait, how'd you do that?
You divide it by gravity.
We figured out the tension in this cable was 216. The tension in this cable is caused by the weight pulling down here. Weight is equal to mass times gravity. So to find the mass, I need to move G over here. So if I took the 216 and I divided by 9.81. Those of you who write too slowly.
But